Me personally?
No, everybody.
I'm just bad at doing the chart quickly. The chart is what takes my time.
Okay, so we started talking about before Christmas break. We started talking about concavity and then second derivatives. We're not just very far into it, which is fine. So there is a feature of graphs that's called concavity. Concavity is the general word that talks about concave up or concave down. So concave up is when it's like a bowl that will hold water. Okay, a bowl is concave up. An umbrella is concave down. So concave up, you can be decreasing, like this guy's decreasing in concave up. You can be increasing in concave up. So whether it's increasing or decreasing does not matter. It's just about the shape of the graph. This is concave down and increasing. This is concave down and decreasing. Okay, so it's this concavity is, to read this, as what I already wrote, concavity is determined by second derivatives, which is the slope of the first derivative. So like this guy, this graph itself is concave down. What's happening is it's increasing, but the rate of increase is slowing down. So it's increasing at a decreasing rate, which means its derivative is positive because it's increasing, but its second derivative would be negative because the rate at which it's changing is slowing down. It's slowing down. This guy is decreasing, so his first derivative would be negative, but his rate of change is getting steeper and steeper and steeper. Those slopes are getting steeper and steeper. So this is concave down because its rate of change of the rate of change, the rate of change of the slope is negative. Okay, so that's where we have this. It's concave up either if f prime is increasing or if f double prime is positive. Okay, these two things are equivalent. That does not explicitly say that there. So I'm going to do this. It's concave up if f prime is increasing or if f double prime is positive. Okay, so we can determine concavity by looking at a second derivative or by looking at a first derivative. Just a second, Gary. It's concave down if f prime is decreasing or if f double prime is negative. Yes.
What if the f prime or f double prime is 0? Is it just 0?
We're going there right now. Okay, so this is basically what you're asking me. If it's 0, so if the graph is switching from concave up to concave down, meaning that your second derivative is going from positive to negative or vice versa, it's what's called an inflection point. So an inflection point is the place where the graph switches from concave up to concave down. And that is generally, not always, but generally where the second derivative equals 0. Okay, so I'll write that up.
I feel like a bar down.
We did all that written down.
We have.
Hence why it's written down already, Caleb. We're just reviewing. Okay. Oh my gosh, David. I'm having name problems today.
So
Yes.
with the inflection point, if you have a graph that's like
Everybody's
what graph is this?
X cubed.
X cubed.
I do all my graph.
Hey, be quiet, please.
The inflection point would be in the middle at 0, 0. If you stretch that out to be a straight line, so it curves down and then it goes.
So if you zoomed in on it,
basically, so it only has a slope of 0 at
1 point.
Where
1 point. But if you made it have a slope of 0 at like on a line, where would the inflection point be? Like
I know what you're talking about.
Yeah. Would there be 2? Because at certain points it's concave up and concave down at the same time.
It's not both. It just doesn't have concavity. If it's horizontal, it doesn't have concavity.
Okay.
So I guess I would have to say I'm not sure because the definition of an inflection point is that it's specifically switching from concave up to concave down.
So in order to have concavity, it has to have a slope?
Yes. Garrett, did you have a question? Okay. Aiden.
Do we have equations to work with where the second derivative is constant, or the derivative is constantly changing at the same rate, so it won't have an inflection point, it'll just kind of be the same?
For sure. So, for example, For example, you guys are asking this question. This is not David's question. This is Aiden's question, though. This is f of x equals x squared. Concave up or concave down? Always concave up. Never, so it's never going to change, right? Which therefore it doesn't have an inflection point. So if we do his, let me show you why. So if we do his derivative, what's f prime? 2x. What's f double prime? 2. So positive, always positive, second derivative means that this guy's always concave up. Anything below an x squared for the original won't have any concavity. So linear graph doesn't have concavity. Does that answer your question?
Sort of. It wasn't really what I was asking. I just worded it poorly, but it does answer any question.
Okay.
So if it's just not concave,
It just doesn't have concavity. Correct.
I think that's equal to like
Okay. There are other graphs that have concavity, but if we're talking in the realm of polynomials, a linear thing does not have. What?
What's the word for a graph that curves? It's not a graph. Because other like sine.
That's what you wanted? Parabola? Okay. That's okay. Because there's lots of graphs that curve. That's the only reason I was giving you that funky look. Okay. Now, just a second, I gotta find my notes where we are. So what we're gonna do is do some analysis on our equations here.
Are we ever gonna do stuff like unit 2 again? Because that actually did good.
Specifically, what about it?
The entire unit. I got an answer.
Well, I'll say yes. Yes, we are.
Sweet.
Okay, okay. Let's. I don't like any of those equations. Let's do this. Okay. Okay. So what we're going to do on this guy is we are going to find any inflection points, and we're going to go with coordinate points on those. And then intervals of concave up and concave down. So it is very similar. So I think somebody just said that, and I was not paying the best attention. Somebody just said this is another sign chart thing. It is. Because it's the same sign chart process, except we're doing it with a second derivative. Okay, that's the difference. First derivative will tell you maximums, minimums, increasing and decreasing. Second derivative tells you concave up, concave down, and inflection points. Okay, so same process, just that we're doing it with the second derivative, which I feel like we did, but I don't know. So what's the first derivative?
Minus the third minus 36x to the second plus what the freak 96x minus 64.
Yep. What the freak indeed. I understand that. Okay, so second derivative.
Now we gotta do a third derivative. Second derivative.
12x squared.
72.
Nope. Yep.
I got 72x.
72, yeah. 2 times 3.
Oh, I thought a 3 there. Yep. 72x. Sorry, my bad.
96.
Plus 96. Okay.
I stand with David.
Thank you.
It's just because I'm always right. 'Cause I'm so smart.
Okay, so same process. We want to know where this equals 0. So what's the first thing you're gonna do?
Put it equal to 0.
Pull out, yeah, and pull out our 12. I think that's 8. 96 is 8. -4, -2 is correct. Okay, the process is the same. What are the values that we care about?
0, 4, and 2.
4 and 2.
Not 0. Okay, why is it not 0?
Because there's no X on the front.
Correct. There's no 12 is just a constant. So there's only a 0 there if there's an X out there with it. Okay, so
Now we do our sign chart.
now you do your sign chart. So it's going to be less than 2, 2 to 4, and then greater than 4. Whoops, greater than 4.
I can do this sign chart really quick.
So you can put the 12 on there.
It's just always positive.
It's just always positive. If it's a negative, it matters. If it's a positive, it doesn't. So I would put it.
Oh, wait, so you don't put a constant on the.
What did I just say?
Oh,
If it's a negative, it matters. So my thought to you is just get in the habit of putting them on there. That way you don't have to remember that a negative matters.
So then instead of prime, do we just do it to second prime because we use the second prime in the first place?
Yes. To here, you mean? Yes.
Do we plug our numbers back into the original or into the prime equation?
Just a second. Let's fill out our chart first. So take a second and fill out your 3 columns with the correct pluses and minuses, and then just wait. Because Austin asked a question, then Joe asked a question, and I want you guys to hear the answer to both of those. So just fill out your chart. Oh. Question? No? Okay. Well, just tell me. Because the 12 is always positive. Okay. Right, so whatever it is, if it's a positive, it's all positive. If it's a negative, it's all negative.
I already forgot.
Okay, so Austin asked this question. This stuff multiplies back to be what? The second derivative. So this is f double prime, not f prime, because we're working on the double prime right now. Okay, so then this is positive, negative, and positive. This, though, is still f of x because it's the second derivative that's telling us about the original function. So if this is positive, if f double prime is positive, this is concave up.
Aw, shoot.
Okay, concave.
Go.
Concave up. Whatever. You put up, down, it doesn't matter what you write. It's just what I write. Okay, this is negative, so it's concave down. And this is positive, so it's concave up. You can put CCU. What about I can put CU? I don't care. Put CD. Doesn't matter. Your notes, because I'm not reading your table. You're gonna write it for me anyway on a test or whatever.
So this has 2 inflection points, right?
It has 2 inflection points. So it has to be that an inflection point has to go from concave up to concave down. It has to switch concavity. So if we went concave up to concave up, not an inflection point, even if it did equal 0 there. Okay? Question? Okay.
I just noticed it's the same process as finding maximums.
It absolutely is the same process, which is why this shouldn't be awful. So this is 2 and 4. Those are our x values of our inflection points. And then this is the question Joe asked. If I need a coordinate point of an inflection point, where do I plug the 2 into? The original, because I'm getting information about the original. I'm not getting information about the derivative here. I'm getting information about I'm using the second derivative to get information about the original. So it goes back into the original, whatever that happens to be, something terrible. Yeah, it is a big equation. Minus 64 times 2. Oh, crap. I got negative 16 for the first one. Anybody get that?
Yes.
Okay.
Yeah, me too.
Anybody? Yeah, I'm sure. I can tell that voice. Anybody can do the 4? What'd you get?
0.
Well, you got 0 for the 4.
I trust her. I would have guessed negative 32.
I trust my word.
You also got 0? Okay. I'd just like to have at least 2.
I trust her too.
Yeah, I got 0 too.
Yeah, I know that tone of voice too. I also got 0. There we go. So there are our 2 inflection points, and these are our intervals where it's concave up for x is greater than 2, and x less than 2, x greater than 4, concave down between 2 and 4. So it's good.
Is there a way that we describe the, what's it called, the inflection things?
It would be their coordinate points.
That's it?
That's just it.
Okay.
Oh wait, how would you like us, if we had to, like how we have to do increase and decrease?
Just it would be the same. So you always be like,
How would you like us to write it? 'Cause, like,
so if it was a test or whatever, like you would say this is concave up
You're right.
on x greater than 2 and x greater than 4, like just like we did on our warm up. Okay, because I'm not reading your table, and I'm not reading your table because they won't read your table on the AP test. Okay, they will say explain why. So you would have to say, hey, I know this is concave up on this interval because why? What reason would you give them?
It's increasing.
The second
Don't say it, bro.
derivative goes from constant to
Okay, hang on. Listen to my question again. You guys are just not answering the right question. Why do you know that it's concave up on this interval? Because
Increasing at the second derivative.
because the second derivative is positive. Okay, so this is this thing that we've talked about a little bit on and off, that you have to be really careful about how you answer your questions, right? To get all of your points. This is, if we're talking about concavity, you have to be talking about the second derivative or the first derivative.
Does this help you draw out size?
If we had done the analysis on the first one, yes.
What does it tell you?
It just gives you, so I'll tell you the first one. The first one factors to x and x minus 4 to the third. So pretty much, I'll show you the graph because it's in the book. So right here, this is what the graph looks like. So if it was me and I was doing this, I would be like, oh, okay, I know I've got a minimum. This is flat, right? And so I know it's going to level out, but then I can be like, oh, concave down here, concave up here. It's really just a way to verify and smooth it out a little bit more. That's basically, other than the exact intervals where it's concave up and concave down. Okay, Caleb.
Why did we use the second one, not the first one?
The best answer I have for that is because direct analysis, so the factoring and finding the zeros, gives us inflection points if we use the second derivative only. So the first derivative only gives you maximums and minimums and increasing and decreasing. So if I specifically am asking for where is it concave up and concave down, you've got to use the second derivative.
On the equations, like the one up we had where it says we have to draw the graph at the end, on the AP test, will they expect us to do the second derivative so we know whether it's concave?
No, they're not going to ask you to draw.
Oh, okay.
I wanted you to draw so you could kind of make a relationship there and see what it looks like. Okay. Yeah, thank you, Mr. Hanson. Okay, so let's. No,
Mr. Hanson.
I said Mr. Hanson because it sounded like Caleb said something about the relationship.
Oh, downplay.
Yeah. Okay. Let's see. What do I want to do here? I want to do this one. So let's go. F of x is equal to x squared minus 2x plus 4 over x minus 2. This gives us a good review. So I want us to do both of these. I want us to do first derivative and second derivative, both. Okay, so we're going to find all of the things. Okay, where is it increasing, decreasing, maximums, minimums, concave up, concave down? Okay, so I'm just going to write all the things. So what I want you to do is, correct, first derivative first, and I'd like you to pause once you have the first derivative done and make sure that we're all operating on the same wavelength. Go ahead. In the scheme of derivatives, this one's not terrible. What's the derivative of the bottom? So that makes it not too terrible.
Do we stop here because we can cancel?
I don't think you could cancel.
You can't cancel at the bottom.
I think I get what you're saying, Austin. Minus 2x plus 4 over x minus 2 squared. Should have this for your, right? But you have to expand this first part before you cancel. So I don't know if you're asking me this, but you can't cancel those two, Austin, because you don't have any x minus 2's over on the right-hand side.
Oh shoot, I forgot about it.
Okay, so distribute the left and simplify the top down.
Distribute the left.
And then do we bring it back, separate them again?
So what do we get on the top? When we're all done, what do you get on the top?
X squared minus 4x plus 18.
No.
I'm done. I got x squared minus 6x.
I did it. X squared minus 8x plus.
No,
X
Alex
squared
got the
minus
same thing as
4x.
Kenny, so I trust Alex.
Minus x squared.
I got x squared minus 4x plus 18.
It's x. You guys, what are
It's
you
just X squared
doing?
minus 4x.
It's just x squared minus 4x.
Isn't that what Caleb says?
No. He said plus 16.
Oh, 16?
What'd you plus on the end? 18? Something.
Yeah, 8.
Okay, still that's wrong. Okay, look, you guys, when you multiply this first thing here,
17?
you get 2x squared minus 4x minus 2x plus 4. It's 4. It's 4. I don't know where you're even getting anything in double digits.
I don't either, but hey, Alex got it too.
Distribute the negative.
Oh, I had a 14 in there.
Oh, I can
There's a 14 up
yeah,
top.
I can see that. It's a plus 4.
Oh,
Okay.
that got me tripping.
I always had a 14 too.
That's why. All right, just a second. So then when you simplify, the 4's cancel, the 2x's cancel, and you combine those guys, you have x squared minus 4x over x minus 2 squared.
That's what I was doing. Yes, you're actually.
Okay, just a second, David. Okay, now, what we're gonna, I would not cross this out. You're gonna have to do the derivative of this again in a hot second. But you do need to factor the top. So how do you factor the top?
Take out an X.
Yep. So then what's on the top? X and
4, negative 4.
x minus 4 over x minus 2 squared. Now, we did one of these before break with the first derivative, but it's been a while, so I want to review it again. Now, David.
Can I expand on?
No. Don't do it. Garrett, question or just stretching? Okay. So, what are our critical values?
0 and 4. And
Okay, now listen. 0 and 4 are critical values. 2 is technically not a critical value, but you have to use him in the table because he's an asymptote. Okay? And we know he's an asymptote because in the original,
it's undefined.
it's undefined at 2. but we still have to include that in our table because something's going to happen at the 2. Okay. It's not going to be a maximum or a minimum, but it does cause things to change. Think about how asymptotes can behave. It could cause. So we still have to use the 2 in our table. Okay. Now, Caleb, what's your question?
Is it called an asymptote because when we use it in the table, but we have to pull it out, it's a pain in the
No.
asymptote?
Thank you for that. I appreciate it muchly.
That's full point material.
No, that was dumb.
Everyone.
I did not give myself enough room there. Okay, so you've got 3 pieces here. You've got the x, you've got the x minus 4, and you've got the x minus 2 squared. If you want to break it up into x minus 2, you can, but that bottom will always be what? When you're thinking sign charts. Positive, because it's squared. So it's okay to leave that squared like that. Okay, go ahead, fill it out. I'm looking for f prime and f of x. So we're looking for, where is it increasing, decreasing, any maximums, any minimums? Yes.
It doesn't particularly matter with the sign chart, but wouldn't it be 1 over x minus 2?
It does not matter because multiplying and dividing is the same in terms of negatives and positives, right?
Yeah, I'm saying it doesn't, but I'm just asking, like, would it be?
No, you could, if it offends your sensibilities, multiply by 1 over that,
Okay.
which is the same as
That's
dividing.
what I wrote down. I just want to make sure I wasn't getting it wrong.
Are we
Is
gonna,
that a double front?
No,
are we
That's
gonna
fine.
do it again? Can I?
But this is just because we're doing extra review, right? We wouldn't normally get one where they make us do the prime and then the double prime, because there's no point, right?
why is there no point?
Because it's telling you the same thing, just in different words.
It's not telling you the same thing. I cannot look at this and tell you where there are any inflection points. So yes, you're going to have to do both of them.
I understand on this one.
Yes.
Okay. I thought the inflection points were just
So
good
we're
for
gonna
telling
have
concavity.
to we gotta do this on one
But that's a different thing.
Yeah. I see.
like a 20-point exam problem. Probably be 3 of them on the test.
Yeah, do we have an exam in here or is it just the AP test?
Haven't decided yet.
Okay.
Depends on how good we are, guys.
You better not base it on that.
See, Sarah, you already talked about how we were gonna have a quiz, and now we never had a quiz.
I'm glad for that.
I am too, because I was really looking forward to a quiz, and then I was really not looking forward to it.
I never look forward to quizzes.
I thought that it would help my grade, and then we
Some critical numbers.
Okay, so this guy's increasing on what intervals?
X is less than 0 and X is greater than 4.
Yep, x is greater than 4. Decreasing?
X between 0 and 2.
So you can write this 2 different ways. You could go 0 to 4 with x not equal to 2 if you really wanted to. Garrett, why are you talking? Or you could write them both separately, like they're written. 2 to 4. So that's basically the same there because that's all of those. Okay, doesn't matter. Now, bless you. How about, are there any minimums in this graph? Where?
4, 6.
4, that's his y value is 6.
I think so.
Okay, I'll trust you.
Me too.
4, 4, 4.
Yeah, I just got it.
It's not 8. Oh, it's 4. It's 4. Sorry. I was plugging in a 2. How about maximum? That's 0. What do you get? -2, 0, -2. Now, question, what's going on at 2?
It's a
Just
plateau,
decrease.
but
It's not.
Oh, shock.
What is it? What's at 2?
Vertical.
It's an asymptote there, right? So it's so tempting to be like, hey, this is a plateau because it goes from decreasing to decreasing. It's a vertical asymptote because you've got to go back to the original. Okay. If it helps you to write that, there's a vertical asymptote at x equals 2, go ahead. You don't have to, but it might be a good idea. Then you don't think that it's some kind of other critical point. No.
Tells you, hey, you don't really need it, right?
Does. Alex.
Wouldn't the max be at 0 positive 2? Boy.
No.
I'm reading that next one.
Because positive over negative is a negative. Okay, now that's the information from the first derivative. Now we're going to do the second derivative and get the information from that. So here's your equation. You don't want to do this one because then you have to do the product rule on the top. Okay, so we've got f prime is x squared minus 4x over x minus 2 squared. So this is not a pretty derivative. Or second derivative, I guess. Okay, please do it. You have to use the quotient rule and you have to use the chain rule on the bottom. Yeah, it totally is. Mm-hmm.
Did you say we can move it up?
You can. Then you have to use product rule, but yep.
Is that what, did you say we should do that? I kind of zoned out.
I didn't say that. I don't think I would though. Because you would have to have it as one fraction to do the sign chart. So if you could move it up, but then it's not a fraction. You don't want to do that.
Didn't you say to move it up, it was just like one variable or something like that?
Mm-hmm. Like if it's just a constant on the top, that's when you want to move it up.
Did it become to the fourth on the bottom?
Or, yeah.
Mm-hmm.
I don't remember if you add or multiply, but either way, it's still.
Yeah, that's true.
You do multiply them.
Because when it's to the exponent, you multiply.
Another day, another drawing.
Okay, before you do anything else with this, what are you going to do?
Oh, you can take the x minus 2.
Pull out one of the x minus 2's, right? So this is going to go away. One of these is going to go away. And one of these is going to go away. Okay, that's going to make your simplifying life significantly easier. If you don't catch that, you will want to cry later. So maybe more than you do now. You got to expand the first one and distribute the -2. I would like to pick up with this first thing tomorrow. We'll finish up the lesson and then I will give you homework time.
Question for you,
Yes.
Are we going to our clubs from last semester?
I don't know yet.
I really hope not.
I have not gotten any